pieces, but it could be the tech cables.
It's 75, Michael.
For the whole meeting, thank you. Maybe. I'm going to put it, I'm going to try to.
Hello, everybody. Welcome. Welcome to the July meeting of the Hazard Mitigation Committee, where our special presentation tonight is through SLR International, which is the consulting firm that the town and the state of Vermont have engaged to finally learn how does the Great Brook behave? How does the Great Brook want to change things? What kind of ultimate choices do we have to make when there is a choice between rebuilding a road or a bridge or giving the brook the room that it's asking for? So presenting from SLR today are Roy Schiff at the end of the table, as well as Ethan Ely, who's a little closer to me. And then with members of the committee, we have Maggie Baird, Carla Siegel, Jim Dorino, David Hill, and myself. And I'm not going to ask everyone in the audience to identify yourself, but I do want to point out Steve Libby from the Vermont Emergency Management, who is here participating. And I think from here we can just take it forward. Let me pass the mic down the table.
Yep, the size of it. I think I'm going to stand up. Get close.
I'm sorry about that. That's for a slightly shorter person. Let me raise it.
Got it? Okay. So we're here for the third public meeting to talk about Great Brook. And again, this is a flood mitigation study sponsored by VEM. And excited to be here. Slide. All right, so agenda for tonight, give you a progress update, what we've been up to. Look at the schedule. Ethan's going to dig into the good stuff, the hydrology and hydraulic modeling to represent the brook. And then we are just kind of getting going. We're a little behind getting going on the flood mitigation alternatives. And so that's what we'll talk about at the end of the meeting today. And I want to preface all of this by saying, one, Francis, just so you know, like, that's up on the screen here.
Yeah, there's nothing we can do about that.
Okay, all right. You know, as you were talking, keep in mind of flood mitigation alternatives in your minds. We'd like to hear some ideas. We've got a few things written down from our previous meeting. So if you have any information from the flooding that took place or thoughts on Brook Road, I know there are other consultants working on that, but it's a big part of the flood mitigation story along Great Brook, and also the bridges. Please keep that in mind and let Ethan and I know as we're going. Next slide. Okay, so here's the update. The main thing we've been working on is we've gotten the green LiDAR. If you recall, we were waiting, we kind of missed the fall window of doing the data collection. So we got that green LiDAR in our sub-consultant Whiteout Solutions out of Lindenville. They were able to process the data, and we'll introduce that to you today. It's a really neat data set. And then we've been working on the hydrology and hydraulic model setup, and Ethan's going to talk a bit about that, and also validating it compared to some of the information that's been collected out on the brook. Finally, we've been working on the alternatives analysis, so we have an expanded list of alternatives to talk about. We have been coordinating with the consultants doing the Brook Road project, so we're pretty much in alignment, understand what they're evaluating. And like I said, I think the two projects kind of go together. And then we're also looking at floodplain restoration and bridge changes along the brook. And we'll show you an initial example of some results tonight. Here's our project schedule. So we had a little bit of a pause right up until July when we got these data. And so we're going to be working in earnest the next few months to try to wrap things up in November. We'll have a report ready. I think we'll talk with Michael, but if you see, you know, we're here in the June 6th, that should say July actually, 16th meeting. But I think we might try to sneak in another meeting to share some more alternatives because we're getting a little behind in terms of like we wanted to share more results. So, and then we're going to do some concept designs of the top few alternatives. And we'll come back and just present those right at the end of the project along with the report. Okay, so here's the green LiDAR. In summary, it talks a little bit about what the sensor is. And this is a little bit of a unique data set. Only a few spots around the state have it, but it's growing in popularity for this kind of work. And we covered 10 miles of a little bit of the Winooski at the confluence, and then up Great Brook, like 7-ish miles. There's about 40 meters on each side of the brook that's covered. So it's about an 820 acre data set of this really high accuracy topography. We're going to show you one use of it. The town's going to have this data set and be able to use it for a lot of projects in your future. So it's a really valuable source of information. It comes on with the standard datums that people use in Vermont for design work. What I wanted to clue in on is the vertical accuracy is about 0.2 feet. So it's pretty much survey grade information across this whole corridor. At the time the information was flown, and the horizontal accuracy is about a foot. And you can see in the right some imagery. We'll look at it closer at the next slide. So Winooski's on the bottom left, sticking up vertically, and then this is the Great Brook corridor, bends up, and this is one of the hillshade products. You get a bunch of different products, and something we like to look at is the hillshade. Shows the topography and the shape of the land. It's great for putting behind plans and whatnot. Next slide. And then this is kind of the heart of it, and this is, I just wanted to zoom way out. We're going to start out and zoom in, and this is a point cloud. And if you look at the classification, the different colors, each one means something different. So this information can penetrate through different layers. So one of the neatest things, go to the next slide. So here's a zoom in of that point cloud, and you can start to really resolve like every building. You can even make out some of the utility wires that are hanging, because this thing has such a high point density. And you go to the next slide. And one of my favorite features is from the top left, top right, bottom left, you can just turn off the layers and really look at any specific layer you want. So if you wanted to do a high vegetation survey, like you would now have that across the Great Brook corridor. And if you wanted to look in the right of just the topography on the land as well as the river channel, because this green LiDAR sees through water, and then you can kind of do that, and you can do everything. You see the roads in between, the water surface is light blue, the buildings are orange. So it's a really valuable, powerful data set that's really ideal for hydraulic modeling. I think, let's see, slide. And then here's a cross section. So in the model work, let's start on the bottom two. The bottom left is a 2023 state LiDAR. It's got a pretty good accuracy, about a 1 foot accuracy. And again, on the right, where less than a foot vertical, about a 1 foot horizontal. And this is just an example to show a little bit of increased detail on the right, but also you can really see the changes in the brook. Like these are the two same spots. This is one of the spots up near Gray Road where the river migrated into the roadbed, which is right here.
Excuse me, Roy, is that what we call the Grand Canyon?
I guess there's a couple of Grand Canyons out there, but I think this is...
I think this is the one that Carl and the road crew call the Grand Canyon.
Okay. Yeah, so it's sitting on the road. And then if you look in the upper right, a really astonishing view of how the brook has changed. And interestingly, so the dark blue line is the 2023 LiDAR, and then the lighter, it's like a gray line, is the 26 that we just flew. And you can, the most obvious thing is you can see the whole roadbed's gone, right, on the right side of this plot. But you can also see that the riverbed actually built up a little bit where the former river channel was, something we all see commonly out there. The river goes up and down and moves side to side. A little bit of changes on the valley wall. That could just be a little bit of an accuracy thing. You can see the shape is translated over. So a good example of the data set, yeah.
So that's a cross, the chart on the top is a cross section?
Yes. And
what point?
So
in the river?
So it's actually a cut. So if you're standing in the river looking at the Grand Canyon from upstream and downstream, it's a line across the river. So like the left side around 0 is on the left side of the river channel, comes across, and then the low spot in the middle is where the river channel exists.
Can you show us on the map where the cut is?
Where the cut is?
Where that cut is?
Yeah, so let's see. A pointer. So the cut is probably like right through like there.
I think it's higher, Roy.
It's a little higher.
Yeah, I think it's because that huge gulf that's on the upper right of your right-hand slide, portion of the slide, is where that enormous collapse of material occurred.
I want to say it's like right.
There you go, you got a pointer now. Yeah.
So the beauty, one of the beauties of this information is you can take cuts across the river or a profile up and down the river, and get the difference in shapes and look how the river's been adjusting. And then we'll eventually go in and manipulate that, like we'll put the road back, or we'll give you a little preview, like maybe we'll put a narrower road in, or we'll pull the road out like this. So those are just options you can sort of play with the terrain and test alternatives. So I think that's the summary of the green lidar that we're working with. We got this a few weeks ago now, and we're working in earnest to get the modeling update. And I think Ethan's going to take over from here and walk us through the modeling.
Hi, everybody. So I'm going to walk through kind of what we've been doing so far. We've been working on this for several months, kind of trying to prepare for when we got the LiDAR. Now that we have it, we've added that into our model, and we're now using that. So we were kind of waiting around to finalize the modeling and get the real detail in there until we had that accurate data. So we're actually representing what exists now. So we've been kind of holding off for a little while, but also making progress, just kind of like getting ready for that data. But now we have it. So what have we been up to? We've been taking our model and updating what we call the geometry. So it's the data that goes into the model to do all the calculations. We've been estimating flows and kind of looking how those compare to measured flows. We have some data from various folks in the community. From UVM, they did some flow measurements at certain spots along the brook. And we compare what we calculate to what they did to see if we're matching reality. That way we know we're at a good starting point before we start playing around with things and changing things. That validation, so that's what we call validation, right, for our model. The one we're going to be talking about is called the rain on grid, and I'll explain what that is in just a minute. But the idea is it's rain falling down on our model, and we kind of calculate the flows from that. And now we're in the process of starting to test those alternatives. So, right, taking existing conditions, making some modifications to our model, and then seeing how the flood reacts to that. Seeing if we can reduce flood levels in some places, seeing if we can slow water down in some places, reduce erosion. So we're kind of playing with that by doing comparison to existing, and then doing some changes and seeing how that happens. Once we get all this, the model fully set up, we'll have a little bit more calibration left, and then we're going to be running through a bunch of alternatives, which we'll explain here in a little bit. All right, so you're going to hit the video. You should be able to just click and it should go. Nice. So if you can see here, right, if you watch what's happening, this is like a terrain surface, and you're watching as the water builds up on it, builds up, and you're watching that flood move through, right? And the way we kind of evaluate that in graph form is this hydrograph, right? It's flow of the brook over time. And what you saw was just the water as the rainfall builds up, as the storm moves through, the flow builds up, and then it kind of moves through that area. So in the video, right, you're watching all the water from all around come into the brook and then kind of increase until it gets to that peak and then drop back down again. So here's that peak, and then it's starting to decrease again. So this is our rain on grid model, right? What it is it's a digital mesh, right, in our computer, just a bunch of grid squares. We tell it how much rain falls over what time period. We tell it what the ground looks like, what the soils look like, what the slopes look like. We give it that terrain, that LiDAR that we had. And then we let it figure out where the water goes and how much water it produces, pretty much. So we're telling it, okay, this soil is really tight, it's not letting much water infiltrate, more of that's gonna flow off. And we're gonna see that in that model. And each of those little grid cells calculates separately how much water is produced from the rainfall, and then transports it down through the model, and then eventually you see it moving through the brook right there. So this is just kind of a little video clip of what the results are from all of that data input going into the model. And then from there, we're going to take all of that and start messing with the terrain, messing with various features, changing the bridge sizes to see how that affects things. But the rain on grid's kind of taking what we traditionally would call a hydrologic model, calculating flows, and a hydraulic model, calculating how that water moves across the land, combining it into one, and then letting it kind of do its thing. This is a more advanced sort of software that we haven't really used a lot until very recently, past like 5 or so years. Yeah, do you have a question?
I'm not a geologist, so
Yeah.
forgive me, but what is the granularity of the data that describes the soil?
Yeah, so we get that data from something called Web Soil Survey. I can't tell you exactly, because I'm not sure how accurate it is. It's based on a bunch of soil samples and things like that. They have a map of that. You can go online, look at any area of the state, and they'll have a map of the soil types. What we do is we download that data, and it's pretty much they divide it up into different soil classes for, you know, is it a clayey soil, is it a sandy soil, and then that's mapped, and then we can enter that into the model. So it's relatively accurate based on the number of samples they've taken in past. So, yes.
In this particular animation you just showed us,
Yeah.
you didn't say what your pre-calculated rainfall was, whether it's a 3-inch or 4-inch or 5-inch rain.
Yeah.
And I wonder if you could both tell us that and what you tell the model in terms of the absorption of the soil. Is it when the soil is dry, when it's been just rained on, you know, that kind of thing? And do you run multiple models? So several questions in one.
Yeah, I think I'll get into a little of that more in a few other slides, but in general, we're looking at, so we're taking our rainfall data from something called NOAA Atlas 14, right? So it's taking statistics of the rainfall that's fallen. They have gauges around, and they've calculated, okay, in this frequency, this probability, you get this rainfall, right? So like for what they call a 100-year or like a 1% chance storm per year, you're getting 7 inches over 24 hours, or it's 4 inches over 2 hours, right? They have it over a certain duration. And that's very important, right? Because our watershed here, it takes, when the rain falls on it, it takes a certain amount of time for that water to get from one point to the other, right? In this case, depending on the storm, it can be anywhere from 1.5 hours to like 3 or 4 hours, right? For that peak to go through. Almost just pulled the mic. So when we're looking at a storm, we're looking generally at a 24-hour storm, but we tell the model kind of a standard sort of shape for that rainfall, right? And that's based on combining some of those duration in that data, that statistical data, into kind of a single curve and then applying it to the watershed. So you'll see, if we were to show you the rainfall data, which I think we might have one slide kind of showing some rainfall data from the 2024.
Yeah, that's from real data.
Yeah, that's from real measured data. You know, kind of shows how we put that in there. It's spread over a certain amount of time, and that's pretty important to how it affects things. In terms of the infiltration, we tell it the type of soil, and then there's a standard sort of equation called a curve number equation based on the NRCS, what is it, Natural Resource Conservation Service, that calculates how much of that water goes in and how much of that water moves across. And so for our whole model, for every single cell, and there's about 100,000 cells in the model, it's doing that calculation, and maybe it's a 50-foot cell, maybe it's a 10-foot cell, and then it's telling how much water should move across that. We'll go into a little bit more of that. I don't know if that fully explained all of it, and if we don't hit it, please remind me and we'll go back to that. There's the rainfall data. I knew it was somewhere in here. So inputs, right? I told you there were soils, there's the terrain, there's this rainfall data. So we have a bunch of good rainfall data for this area. We have rain gauge measurements from various storms. I think it was Hurricane Hugo or Tropical Storm Hugo. We have the 2024 rainfall, so there's various gauges throughout the watershed. You can see in that graph on the left, that's what the rainfall looks like, right? You have a certain depth of rain kind of spread out over a certain number of hours flying across the landscape. And this is the kind of more coarse level of the data. And then we put that into the model and let it tell us what the flows are. But you can see, right, there's the various gauges. We have a couple different ones graphed on that graph showing different rainfall depths in the watershed.
I'm seeing 200 hours. That's like over 8 days or something?
Yeah, because those were daily measurements, so it's kind of showing on each day the depth for that, yeah.
Thank you.
The one, it is a little confusing because the one day, right, that big spike, that's when you had the big storm come through. And then what it produces, right, I was telling you, it takes that rainfall data, turns it into flow, and then we can go into the model and look at what that is. So this is in their hydrograph, right, flow over time, and it's showing the peak on Great Brook where it meets the Winooski River of about 3,500 CFS, which is matching up with what the flow measurements were, estimates were by UVM, and I'll talk about that a little more in a sec. But we're pretty much taking rainfall data, and we're turning it into a flow curve, and we're looking at how that moves across the land with the model. So this is our validation step. This is one thing we've been working on for quite a while now, trying to make sure that our model represents reality. In that top picture, that is some of the results of the hydraulic modeling. So you'll see all the blue, which is depth, that's flood depth, right? This is downtown Plainfield. And this is that 3,500 CFS, cubic feet per second of flow. What you also see is a yellow line, and that is high water marks that Roy walked around and marked out after the flood. So right after the flood, he was out looking at where there's sediment deposits, looking where there's debris, mapping out where the flood extent was and the elevation. So what we're doing is to validate our model to make sure it is reflecting reality. So we graph both of those together, and you can kind of see the yellow line matches in some spots really well what the flood depth, the edge of the flood depth is. In other spots, it's a little off. And there's a lot of reasons for that. One thing we're finding is the bridges were clogged with a lot of debris. So in this model, right, we're doing different runs to see, okay, was the bridge clogged? Was it not clogged? And how does that affect the depths? When you clog the bridges, you start to actually meet a lot more of those yellow lines, because in reality, the bridges were not open, right? They were full of sediment, they were full of debris. So we're trying our best to match reality, but in some cases you have to make some assumptions. But this is one way that we look at the model and say, like, okay, is this real? Is this showing us something that did happen? And then from there, can we change it to see if we can improve things? Another way we did that is we have some UVM did flow measurements at 2 different sites. There's one called GB1 and GB2. And they came up with a range of flows for that, right? Based on a couple different factors, the cross-section of the channel, the slope, a roughness, and they get kind of a range of flows for that. Then next to that, we have the model results, right? So there's a 100-year storm, so that's based on that NOAA Atlas 14 rainfall, and then a 500-year storm. This is not saying this is the 100-year flood, it's just based on the rainfall data, that's what the storm would be. And if you look at the ranges, our 100-year matches up pretty well with that. And so our goal is to really try to replicate that 2024 flood. That's what these UVM flow measurements are from, the 2024 flood. And our 3,500 cubic feet per second at the confluence with the Winooski River is pretty much right in the range of what they're guessing we had. So while our model might not be representing the rainfall perfectly, right, we had that 24-hour measurement of rainfall, we're getting pretty dang close to in the range. And we're seeing that with the flow at the gauged, or the measured sites, and we're also seeing that with our high water marks. So we know we're somewhere within reality, depending on what factors were happening during the actual flood, and based on a lot of assumptions. But so that this gives us some confidence that we can move forward and say, this model is gonna show us something that could be real, a real effect. That's the important thing about validation, so. All right, I'm gonna get a little more into just the kind of model inputs, right? So we had our LiDAR terrain, we had the green LiDAR, so that's going up about 6.5 miles up Great Brook. It's about a 40-meter wide. You can see on the left there, that's that 40-meter wide slice as the helicopter flew along. And that's capturing channel banks and topography and all of the slopes and things like that in the channel. And it's cutting through the water, so we're seeing the bed of the stream when we do that. Other input data we have are grid cells. So this is what I was just talking about with the grid cells. You can see there's little squares and there's other little shapes in there. Our average cell size is about 50 feet by 50 feet. That's over kind of the full watershed. And then in the more detailed areas, we get down to maybe 5 or 10 feet. So a little 5 or 10 foot square in the channel, along bridges, along structures. We then tell the model where where the channel is by putting in these lines. We tell it where berms are and ridges and embankments, and all of that is added in to tell the model what the ground looks like and show it where the cells should be. So this is quite a bit of work kind of manually going through and telling the model what it should be focusing on.
May I interrupt briefly
Yeah.
and just say, I believe we're looking at where Cameron Road meets Brook Road.
Yes.
Is that correct? Yes.
Yep.
Whenever you can position a slide like this, I think it would be helpful for everybody, you know,
Yeah.
in terms of saying where we are. And
Yeah, good point, thank you. Yeah, Cameron Road's coming down and kind of meeting up with Brook Road right there at the bridge that we're calling GB-03. Another kind of comparison, kind of looked at one of these earlier, of the green LiDAR versus the 2023 LiDAR, the state LiDAR. And you can just see, I guess one thing to look at is just how different the channel is, right? You can see a lot more meandering, you can see it cutting through the road, through Brook Road. And so when we're modeling, we want to represent reality, and right now reality is this 2026 green LiDAR. So we've added that in, and now that's included in the model.
Nothing at Gray Road, right?
Ah, good point. Yes, that should be just north of Gray Road, I think. Pretty close to Cameron. I was mentioning land cover and soils. So those are our two big inputs for calculating that runoff and the flow. Here is a map of land cover. So this was done in 2022. UVM did a flight, and they had the data they collected. They're able to say whether there's tree cover, whether there's grass, whether there's farmland, whether there's houses. It's pretty high resolution. You can get individual building lines from this. So this data is all into the model, and I kind of just put it in this picture under the watershed. So you can see these little areas defining our watershed into little sub-basins. One of the last things we've added, so we got a bunch of data from Fitzgerald Environmental Associates this winter. They went out and did some survey of all the bridges. So you can see here, this is what it looks like in the model when we enter in the bridge data. So we go in, we'll have some survey data of the bridge. We enter that into the model, and you can see this is what kind of the bridge opening looks like if you're facing, I guess, downstream from the bridge. So we enter that all in so that the model knows what the shape, the opening size, the slope, all of those sort of factors, and so we can really have detail at the bridges. All right, so kind of transitioning here, we've entered all of our data into the model, we're running the model, and now we're going to start looking at alternatives. That's kind of the next step that we're just diving into now. And how do we do that? How do we start to come up with ideas of like, what can we change? Where can we make modifications? Where can we do projects to help? Some of the things we look at are, where are there constrictions? Where is the river being constrained, or is it being manipulated in a way that it doesn't like? And it's going to fight back on us against. One thing we look at is the bridges. We look at the floodplain areas. We look at constrictions, so where the channel is narrowed or it's been shifted or straightened. And then we see how the model reacts in those areas. One place I wanted to call out is this, again, I think is near Cameron Road, where it comes down just a little farther upstream from Cameron Road, I believe.
That's Fowler Road.
Fowler Road, sorry, thank you. I should have labeled the roads on here. Near Fowler Road. But you can see this big meander bend, right? There's two bridges. There's one bridge on Brook Road and a second bridge on Brook Road, and you have these big meanders that come through. What are those bridges doing? So the bridge that's kind of on the top of the page there, right? You can see it's super red. This is a velocity map. It's super red. It's very fast flow on the other side of the bridge, the downstream side. So the bridge is squeezing the flow and it's shooting out one end and it's just cutting into the sediment. Upstream, what's happening? you suddenly see yellow and you see blue colors. That means we have slower velocities, which means the bridge is squeezing that flow, downstream it's speeding up, upstream it's slowing down. It's building that water level up, and that is also described by the flow depth. So upstream of the bridge is 13 feet deep, downstream it's 5 feet deep, and in some spots it's 3 feet on kind of the floodplain area. And with the velocities, you have 7 feet per second of the water moving upstream of the bridge, so it's relatively slow, and then downstream it's over 16 feet per second. So the water slows down as it hits that constriction, kind of builds up in depth up to 13 feet, and then as it squeezes through, it shoots out the other side and speeds up.
Yeah, just quick addendum that in the upper meander to the right is 1735 Brook Road. For anyone who's familiar, there's a house in there.
Oh.
And the bridge that is the downstream one, closer to the top, is the one that is failing and has actually been constricted for traffic now. And the other one is not in use at all. So thank you for that.
Yeah. And one last thing I want to call on this image, right? So this again is telling us from just seeing this where there could be an issue and where we might make a change. Maybe we make that a wider bridge, right? Just to get the water through easier and not have the erosion downstream or the flooding up. But another thing I want to call out is the other bridge crossing. The colors are a lot different there for the velocity. And you can see it's also quite a bit wider. And that's telling us another thing, right? As the river cuts through or knocks out the bridges or widens, it starts to slow down. So one thing you might want to try here is a wider bridge or a wider section of the floodplain, or kind of spreading that flow out to try to slow it down, reduce the erosion, and then also, if you can spread it out, you're lowering that depth. All things that can help with erosion and flooding. So these are kind of the first steps we're taking right now. We're taking our results and saying what's happening here and what is that telling us. And I think this kind of shows that pretty well. All right, so now we're going to kind of go through some of our initial alternatives that we're starting to evaluate. We're kind of just in the start here, so a lot of this stuff is still just, we're playing around with the model, we're trying ideas. None of it's like projects that are about to be constructed. This is all just kind of ideas, and let's start thinking about what we can do. One of those things is floodplain restoration, right? So that's digging up some of the floodplain, lowering it so the water can get out in areas where we want it to get out, and then it slows it down, and it also reduces the flood depths so that it's not affecting homes and businesses and properties in the road itself. Right now we have in those green squares, those are some areas we've identified as potential, just something we want to try in the model. Even if it's not going to happen, at least we can kind of figure out how that affects things. So kind of moving down through downtown, you can see there's Mill Street, there's the bridge there, kind of on the lower left, and then we have Brook Road going up to the right corner, just to get your bearings. And yeah, we have a bunch of different areas where we're saying, okay, if we lower that, does that help the rest of downtown? Moving a little farther up, we have some spots where the river kind of meanders, and we've said, okay, can we cut that area down to kind of slow the water down again and reduce it before it hits the areas where it gets a little tighter. So this is just a bunch of different spots where we're kind of calling out like some spot where we can test things.
Yes, one thing to add there. So a lot of these floodplain restorations are linked with possible buyouts. Like we're given a map and we don't know how those are playing out. So I just want to throw that out there. Like a lot of communities in their village centers are looking when the buyouts take place, then there's an opportunity to do this floodplain restoration. So just a thought, and these are around a lot of the buyouts that are under consideration right now. So that's kind of where those came from.
And one last thing I guess I'll call out on this slide is there's a kind of a big blue shape that kind of moves through here. All right, it's not just the stream, right? We have kind of a boundary around a lot of the green boxes, that bluish haze. That is called the river corridor, and that's kind of just defining where the river might move if you were to leave it alone and kind of let it do its thing. That's kind of the area that the state has said, all right, this is where the river wants to be. Somewhere in this area, it might bounce back and forth, but it's kind of in this zone. And you can kind of see, we're starting to, like getting those green boxes in there, we're starting to kind of spread out the area that's available for the river to let it kind of move in the area it wants to be. But right now, a lot of that blue covers a lot of the downtown, right? So we're trying to look at like, okay, can we widen this and try to maximize that river corridor that's available so that we don't have to, affect the businesses that are also in the river corridor, but can't be moved or don't want to be moved, things like that. All right, so we are saying alternatives, we have the floodplain restoration. Another option is the bridges. We know we had a lot of bridges wash out from this last flood. And when we went through and had all of the bridges measured, we looked at how they compare to the width of the channel. And in a lot of places, it's much narrower. So we kind of started to rank the bridges, to start looking at them and start evaluating each one to see which should be replaced and which are likely to fail. And usually it's the narrower bridges, the ones that are least, that are matching the channel the least, are most likely to fail, generally. It also depends on structural things and whatnot. But those are kind of the first places to look, like, okay, what can we do to help with the flooding and help with the erosion and help with the bridge failure, widen the bridges. So we're kind of calling out with our number system here. You can see each one of these is numbered. We're starting to call out which ones are the most undersized and which ones we should really start to focus on and start to look at.
And each of these bridges that are numbered are less, 75% or less the size of the channel. Many of the bridges are less than half the channel size. So you really don't have a shot at a long-term, solution there, and there's gonna be a lot of erosion around there. And just so you know, like V-Trans state standard is 1 times the bankfull width of the channel is the standard for the width of the bridge. And so there are other bridges that are not shown, and there's a few of them that are over 1 times the bankfull width. But these are all 0.75 or less.
And I just throw out that a figure you've heard a lot is that the Great Brook Bridge, which we are repairing constantly over and over again, is 40%. And this was from an older figure measurement that Malone and McBroom did back in 2012 or something like that. But yeah, we've always known that we have undersized bridges.
And the data shows if you have a bridge that doesn't fit your channel and doesn't give a little room for debris and wood and sediment that's going to be coming down through, you're likely to have failure. So making it as close to the channel width as possible, as wide as possible, so that you can get all that stuff through is beneficial. Oh, I already did it.
Yeah.
Another option, and this was, VHB is looking at this sort of idea, but one thing we do want to try, and we're collaborating with them on, is potentially realigning the road. Can we get portions of the road that are the highest risk away from where they're at risk and divert the traffic from that, so we don't have to keep repairing them, we don't have to replace all of those bridges. We can do another solution that avoids some of that. So this is one possible route, kind of wrapping around to avoid some of the areas that are highest risk. But we're still working on those as well with VHB.
Which one's the route?
So I probably should call that out. There's kind of a purplish line that kind of wraps up kind of north of the river there. All right, so it wouldn't be north, it would be east of the river, but on the top of the screen. And there's also kind of a yellowish tan that kind of connects up to the road there. Is that east?
There's 2 options.
Cameron Hill,
Cameron Hill.
Road to East Hill.
Yeah, to east. That's what I was thinking.
I think that's Fowler. I'm not sure. It might be.
The one Fowler coming in here.
Yeah.
I'm not sure.
Yeah, I think that one, the small white line, is Cameron, I believe. Yeah. Yeah, and another one, it's kind of cutting up to east.
Yeah, because that's Muskasky Brook coming in the middle.
Yes, thank you.
So that is Fowler.
Do we have those right-of-ways yet?
I think this is all very kind of theoretical and this is more looking at what we would model, but we don't have any sort of idea of where that would be. And we wouldn't be really focusing our model on the actual road itself. We'd be kind of looking at the brook and saying okay, if we kind of leave it alone, what happens?
I have a big question, which somebody in this room might be able to answer. We have project managers for VHB and we have project managers for Du Bois and King. Does the alternative road, the realignment road, have a project manager who is basically shepherding that alternative project along? Is there a named project manager for the alternative route?
Well, VHB is studying both.
Yeah.
VHB has taken that on?
Yeah.
VHB is looking at the alternative.
Oh, great.
And the existing alignment.
Okay.
And when we have our meeting, as a community, we're gonna decide where they're gonna put their time and energy.
Okay.
Yeah.
Great, thank you.
Your project manager, though, is Pat Travers from GPI.
For everything or just portions?
For the work that VHB is doing.
Okay.
I was just
Yes.
wondering, Ethan, if you could clarify which would be the realigned road? Would it be the highest line there?
Yeah, the highest purpose. The first
Well,
one.
Yeah.
those are just two alternatives they're looking at. The purple one that almost looks like a little bit of an M, and then the yellow that connects through, so they're thinking of two, as well as looking at repairing the road or trying to narrow the road. Those are, I think, the alternatives they're looking at, and we've met with them a few times. One thing we're trying to do is, now that our model's about validated, is take the velocity maps and share that with them. And they now have the green LiDAR to use, to try to understand like what the risks are from the river along the road. Because that's a big part of this decision, whether you move the road or not, is how the river behaves along the road. There are some spots where the road and river can coexist. A lot of the spots we've been showing you, there's a big narrow spot in the valley and there's no space for the full-size road there.
Would that new road run through the proposed community of buildings that you want to build off of East Hill?
No.
Okay, I wasn't sure.
It's off the map to the
Yeah, all
left.
right,
Looks like it brings people towards it, but not through it.
okay.
The idea of that new road would be you can see it crossing Fowler, which is the white line on the right of
Yeah.
the blue path of the stream, and it will come back down to Brook just before Gray. That's the thought.
Okay,
There's a lot of detail first, but
yeah,
that's
I'm
the
colorblind, so I'm not good at figuring out what colors you're referring to, so that's
Yeah,
why.
I'm with
Is
you.
that East Hill Road way up at the top, the white line?
Yeah.
Yeah.
Yeah, a little.
Yeah, and one thing I would say about this is like, we're not focusing too much on the actual route itself, right? Most of what we're focusing on is in the river corridor, in the river, what's happening there. And one thing to evaluate with this is, let's say we do not want to have the river there, or the road there. We do want to move it. And we were to take out that road fill, right? What happens to the river downstream when you do that? Maybe it's collecting more of that sediment, maybe it's slowing down more. So that's actually one of the benefits of potentially moving it, is you have a whole stretch where you're able to let the river move and drop sediment and drop debris before it gets downtown. So that's one of the things we can kind of look at, is like, how do those velocities change when you remove that embankment and you remove the squeeze on the river for that. But that's more of the focus of what we would do versus the actual alignment of the road. Yes.
This may be better asked later, so if you want to defer, please defer. I know you guys work all around the state, you work in other states, you're doing all these projects. This strikes me as extraordinarily complex and messy. And I'm wondering, compared to other things you're working on, what's the level of complexity on this one compared to jobs you're usually managing?
I mean, by like, when you say complex and messy, I guess, are you talking about the challenges of Brook Road and Great Brook, or the modeling itself? Like,
yeah,
it's pretty straightforward practice. This is like a lot of common engineering practice, what Ethan's been describing.
Yes.
Great Brook is a very unique setting in New England. Like, there aren't many spots where you have a really steep mountain stream and a road, and let alone a gravel road in it that is so constricted and that has a history of so much failure. Like, most communities are moving roads away from a brook like this because it's complicated, right? And I would say the challenge here is there's no obvious location to move the road. So it's a sticky situation for sure. It's a little complex, or else the road would have been gone a long time ago, probably. It would have been moved. So, yeah.
I would also add that I think this is a little more complex as well, because it's the whole road, right? It's not like we're looking at like this one bridge, what happens here. Like, we had an issue with it. It's more than a dozen bridges, and it's over a mile of road. It's numerous miles, right? It's like 7 miles of road or more. So it's like, it's complex in the fact that there is a lot to look at. And that's one reason our presentation sometimes goes so long, is because there's so many pieces to this, and there's so many things to look at as we do so. So there's a lot there for sure.
Just a quick observation is that we again, something else we've repeated is that the Brook Road is described, and has been described to me from the state level, from the emergency management level, as being one of the top 10 dangerous brooks in the state of Vermont. And it has a uniquely high profile because of the number of times it has repeatedly failed. It's kind of famous in that way. There is terrain in North Carolina where there was a lot of recent destruction, and that is the closest, probably more frequent examples of something similar to what we have. But up here, this is kind of rare.
All right, you're good. We have one last alternative to kind of look at, like I guess category of alternatives that we're going to look at before we kind of wrap things up and just show you some initial results that we're working with. So one potential option, instead of moving the road, is can we modify the road? Can we squeeze it down to one lane in some spots? Can we shift it over slightly in some spots? And then to help with that, can we cut a little floodplain on one side and then shift the road a little bit on the other side? So kind of working with a little bit of incremental, giving the river a little more, but not fully removing the road from it. So you can see this stretch right here. You'll see a 12 and an 11. You have Fowler Road coming down, Brook Road and Gray Road. Between that 12 and that 11, the road's washed out 3 times, I think, in that one stretch. And you can see there's these big bends in the river where it goes through, and it's wherever at each of those bends, that's where the road's gone. So one idea is in that stretch where the road is just so close to the brook and there's really no room in the valley for the river to move, can we shave the meander bend a little bit? Can we bring that ground down a little to get some floodplain? And then can we take that road and just squeeze it over just a little bit, maybe make it one lane, and that's giving it another 10 feet, right? Maybe we have to armor the embankment of the road a little more, but does that really give us enough space to let the river do its thing and not carve its way back into the road again? So in some spots we're looking at like, okay, where is there just enough room that we can maybe do this? Where is there not? And this one spot right here with 11 and 12, maybe we can shave that floodplain just enough to get us some more room and let the road continue to live. Yes?
As a federal connector road, how can you propose going in one lane with all the traffic they're proposing between Route 2 and Route 302?
It's a good question.
Could you repeat the question?
Yeah, I mean, the question was like, can you really modify the road to one lane if it's a federal connector? And we don't know the exact answer to that. Again, our focus is how do we get something in there that would survive longer? And I think we've heard for a very long time about the federal connection and the funding for this road. And at one point they were like, you can't move the road at all. And now they're willing to entertain that. So if we came back and saw the modeling said the flood velocities really drop, the cost to protect the road would drop a lot, we'll really say this is a viable alternative. But this is kind of the key spot here to like keep this connection functioning. That's why it fails. There's one spot here, one spot right near the village that repeatedly fail. So just a thought of, can we nudge it
So if
over?
we run this model and from 12 to 11 doesn't work out, that helps make an argument for an alternative.
It
And
does.
so it's a useful part of the decision
Yeah,
process.
and that's why, and I think our collaborators at VHB understand that. They do hydraulic modeling, so they're kind of now leaning on us to give them this answer and help inform their analysis as well.
Can I ask the question? Maybe
Of
it's an
course.
obvious question, but
Pass the mic.
Okay, thank you.
it's a federal connector, Brook Road, but it's not functioning that way now, right?
No.
So what's happening now?
East Hill. East Hill.
East Hill, okay.
Hmm.
So what about the idea of, reconnecting the federal connector through a different set of roads?
I can answer that in the sense that we work with Central Vermont Regional Planning Commission and their road planner to talk about the possibility of using Middle Road as an alternative. There's a way to get to the same destination on Route 302. But it also means that if Federal Highway Works Administration does not accept that alternative, then they would not necessarily redesignate the road, in which case we wouldn't be eligible for their funds to fix anything. So it's a fairly much a devil's bargain.
And I can point out too that East Hill Road is not a good connector. It's too steep, it's got too many curves.
The people who are needing to drive that road or feel like they need to drive the road are tractor trailers. I mean, we're not just talking about local trucks. There are people who are professional drivers who have it on their maps that to cut from Route 302 to Route 2, you take the Brook Road. And then they find out they can't, they might go down East Hill, but we actually really need to be able to think practically about the size of the vehicles going through there.
I was taking this Carl. Carl, did you still want to speak?
What's that? No, I'm set. No, you got the.
Yeah, okay. So in the previous slide, I kind of just showed you where that road had washed out and where we might be able to do something. This is that same place where you can see the river. This is the results from that model flowing from right to left. And you can see where it's kind of cut into Brook Road, those circles. And the model is telling us, right, with the velocity, this heat map, in those red areas, the river's really moving fast through there. It's really cutting quickly. Can we shave a little bit of that floodplain on the inside of that meander to slow that water down and reduce that color so that it's not such high velocities right along the road and so likely to carve into it? And again, we're kind of looking at the model in various spots. Where are these high energy areas? Where are these danger zones, these risk areas where there's a good probability you're going to get erosion because the water is moving so quickly and so erosively. So this is that stretch along the road where we're saying, can we give it a little more room? Can we reduce that erosion risk in some way? All right, so before we kind of wrap up with our alternatives here, I just want to call out kind of some of our initial results as well. So this is looking at downtown. This is the Mill River, or Mill Street, thank you, bridge. And then you have a couple spots where there could potentially be buyouts. And so our initial look at this is saying, okay, can we take those, if those buyouts happen, and we put in a floodplain, and we take the bridge, we enlarge in that, so we can get more water through there. And then also we have removing one of the old railroad abutments up a little farther at where 6 is, the number 6. So can we take these areas, can we lower the ground down, remove the buildings, and then let the water flow to protect all the other buildings in the area? You can see here, these are some of our initial results. So we took, and you'll see all the blue, right? That's that flood depths again, that's from our model. And then you have a yellow line kind of along the edge there. That yellow is existing conditions. That's the boundary of the water under what our model says is current times. When you then put those floodplains in, the blue is after the floodplains are added and after you widen that bridge. So you're seeing the houses that are kind of between the yellow line, the yellow squiggly, and the blue, those are the ones that are no longer in the water, right? So if you remove and lower the floodplain in some areas, you're pulling that water back into the channel, reducing how much its flood extent is, you're lowering the water level, and you're helping some of the properties right there from being flooded. And there's a yellow line that I've called out as cross-section. So on the next slide, you kind of see what that looks like if you're taking a slice and looking downstream. There it is. This is what that looks like. You can see there's a green line. That is post-floodplain excavation. And there's a little bit of a brown line showing the floodplain before we dig it down. And this is looking again downstream. There's a blue line. That lower blue line is after you put in the bridge in the floodplain, and the upper blue line is existing conditions. So you're seeing about 2 feet of drop in the water level, and you're pulling it all the way back to where we have the floodplain in the channel. So all of that area, what is that? Something like 150 feet. You're pulling that water back to the channel, back to the floodplain where you want the water to be. So this is kind of just one example and some initial results that show what a floodplain could do in the downtown.
Question, is this 100-year flood or 500-year, the top blue line?
This is the 100, but it's pretty much what we saw on 2024, July 2024.
Which is more than 100 or is a 100? I mean, in sense of the typical scale.
So it's a complex sort of question in that
It's between them.
it's about between them. It's somewhere between.
Okay.
Yeah, depending on how you look at the statistics, it's 100 to 500 year flood, and depending on what data you're looking at. So it's somewhere in that range. What we're finding with our model, our results, when that match up to that flood, that's what this is. So this is like taking that 2024 flood, putting it in the model and saying, what can we do? So it's that same flow as what we measured.
I have a follow-up question, which is, if the 2024 flood it represented a flood that Plainfield has never experienced thus far, as far as the historical record says, are you anticipating under existing conditions and rainfall that it could happen again? In other words, that much water could come down the hillside again? Are you taking that for granted?
Yes.
Okay.
We're not taking it for granted, but we're considering it.
You're
I have a
considering.
related question to that.
Yeah.
Is there a good chart of the frequency of the different types of, the different levels of flood event, like the so-called 100-year flood, 500-year flood? Is there a chart of the historical frequency over the last 100 years that would give us the big picture?
So I would say yes and no. There's data online that you can look at that says this is what we say for most streams. It kind of determines based on the watershed size what sort of flood those look like. But every watershed is different, right? That thing I'm talking about is called stream stats. There's a way you can go on and look at flows. But that is not reality. That is an estimation based on the watershed, right? But
I'm just wondering about historical Vermont-wide flood events at the various levels.
I mean, you can do that, and we've actually done a little bit of that over the years on Great Brook. So like every flood that happens, we have an estimate. I think that one of the issues right now is like those estimates are changing, because when you say a flood has like a 1% chance to happen in a given year, it's a 100-year flood, that's based on 50 to 70 years of data behind you. But like last year, or the last couple years, we saw rainfalls we've never seen in Vermont that are like off the charts.
I'm asking about historical data.
Yeah.
So that we can see if the frequency is increasing of the various sizes of flood.
It is, so we know that like.
Data, how can we look at it?
We can get you a table and like compare it to what's been happening both on the rainfall side and on the discharge side.
we have it for different streams. We don't have as much data, flow measurement data for this specific stream. We do have flow measurements, but we don't have every single year, what was that big flood that we had? So it's a little more difficult to piece that apart. Other streams we do. The Winooski, we have tons of data saying what are the flows over 70 years, 50 years, and we can kind of piece that apart. So we do have data for other streams in all throughout Vermont that you can look at that and say like, okay, what is happening? How big are the floods compared over time?
I have to step in here and also say that George Springston, who is in the room, has done a great deal of improvise, sorry, that's the word I'm trying to find. But using your own methods, you've come up with multiple ways of trying to estimate the flows in prior floods.
Yeah.
And that's my sense of things.
Well, I have as they know, we have a flood history we put together and needs a little updating, but we've got a lot of information on the Brook, yes.
Yeah.
But it's all still partial and fragmentary, just like they're saying.
So we can,
And it's on the town website. There's a report on the town website.
Well, it'd be interesting to see it by community rather than by watershed. Like Plainfield has been hit by a so-called 100-year flood all these times in the last 100 years. And, you know, Moortown and, you know, each community, you know, maybe the Winooski one year and Great Brook the next year. But I think to the community, that's kind of, you know, was it the North Winooski, was it the Winooski? I mean, to the community itself, it's
Are you worried about predicting future flooding?
I just want to know how, I would like to have an exact rate of change in frequency of these flooding.
It should be logarithmic.
It's a really tough thing to measure. Yeah. We do have data, but it's just very tough to say. There's a lot of questions, I'm not sure which one. I'm gonna start with you.
Okay.
Thanks.
Yeah.
So I think this is a wonderful graph to look at because it makes obvious what a floodplain expansion can do and what that bench can do. And yet the blue line, the old, thank you very much. The blue line where the old water used to go is so suggestive of what could be in our future anyhow. And that's what I thought Michael was leading to with his first questions. It seems to me that as engineers, you have to be putting in an engineer's double factor into all your calculations because climate change is just accelerating everything. And we can't just go by past data. We have to assume that there's going to be even bigger events in the future.
Yeah.
If can I respond to that? Maybe I'll just do this, yeah, it's a great point.
So there was a question earlier about, do we run, how many kinds of how many floods do we run? Like, the beauty of the model is you can put in any flood size you want. So we have an estimate based on George's measurements and our modeling that this flood was between 100 and 500 year flood, maybe about the 200 year flood, but we don't know that exactly. So the idea is, if we test all these alternatives and we say, okay, here's what really works to reduce erosion, reduce flooding, then we'll just stick in the 500 year flood and see if it's still how protective it is. I mean, you can put in any size flood you want in these models. So that's in our future once we advance the alternatives, is see how it perform in people are asking this question in these like off the chart events. We're seeing 9 inches of rain in an hour. We'll put that in the model and say, like, will the road still be there? Even if we reconnected all the floodplains and moved the piece of the road or whatever comes out of it. So it's a good
I
question.
hope we get away from that 100-year, 500-year language because it doesn't pertain.
It's not accurate anymore. We try to say large flood, medium flood, small flood.
Yeah.
Underlying those numbers is volumetric data, or what's underlying the 100-year flood?
It's statistics based on an old record. So like at the USGS gauges.
No, I get that. I'm just saying there's a volume number of water that it really is pointing to.
That's right. A flow rate that happens 1% of the time.
Maybe we could just learn those numbers and use those.
That's right. It's a lot better approach.
So, yeah, I would just say that we don't know how the localized storms are going to affect us. We had a lot of water hit the top of Great Brook this last storm that came down, rushing down. I was curious, do we have a slope or a grade of the Great Brook from one end to the other? It's a pretty steep brook, which I think is why it gets so destructive. Do we know what it is?
I don't have the number off the top of my head, but we can definitely get that. It does change a little bit depending on where you are on the brook. There's some stretches that are a little flatter, and then it kind of steepens up. But yeah, we can get you that number if you'd like to with a couple of.
Just curious if you were working with that. I know you're working with the engineers, which is really important for the bridges, especially Mill Street and Brook Road Bridge. You're sharing the data that you've come up with to make sure that they're wide enough, that they're taking the full capacity of water that you're predicting.
So we haven't interacted much with the bridge designers, and I think that is something we'd like to get in touch with them for sure. Like, because we've met with the Brook Road team thinking about the alternatives of the connection, but not the bridge folks.
Okay.
So
And
that's something we really need to do.
you do need to do that, because we want to make sure that it's not just water that's going through there, it's trees, it's debris, it's, that's changing elevations of the base of the brook. All those things are what happened to us. And one of the things I'm seeing already, just from rainfall, are collapsing banks into the stream now with new trees falling in. The state did a whole lot of cleaning out, but it's coming all back in. So, and I would also wonder, my last question is, do we have plans or thoughts on how to slow the water down? I like the floodplain idea, but years ago, Lori Berg and George worked on putting in obstructions in the stream to help reduce the energy and slow it down a little bit. It doesn't change volume, but it does change the destructive nature. So I don't know if you've looked at that or if there's options for that.
Yeah, I mean, we can play with all of that in the model, looking at roughness and things like that. If we do give the brook more room and we do sort of a project, we're going to implement things like roughness elements in the channel, plantings on the floodplain, right? Trying to plant the floodplains up so that they're catching more of that sediment, there's more vegetation, all of that sort of stuff slows down the flow. And we can look at certain spots saying like, okay, if we were to install something that kind of roughens this part of the channel, can that slow it down? So we can play with those kind of numbers for sure.
Yeah, so I have a question about flood mitigation. You listed a few different, possibilities.
Yep.
Lowering the floodplain in certain places and that kind of thing. And you mentioned removing sediment as well.
Yeah.
And I'm just wondering about that idea, because would that not cause the stream to cut down and, create higher banks, which would then collapse?
Yeah.
I mean, I guess it's a matter of balancing benefits and risks. Whoops, I should be talking here. So I'm just wondering about that idea and what you could tell us about that.
So if we're removing sediment, we're not talking about like dredging the stream. We're not talking about just digging it down. We're talking about doing it in a way that we're trying to match what the stream wants to be. So in some spots where we have those bridge constrictions, you're seeing sediment build up in them or upstream of them, right? It's slowed down the flow, the sediment drops out, and now we have the bridges partially full, or we have the channel upstream is full. If we widen that bridge, what we might do as well is dig some of that out, but shape the channel in a natural shape. We're not going to be just digging down, we're going to be digging in a channel and then also kind of building a floodplain. Right, so it's doing it in a smart way. It's not doing it in a way where you send a shovel up the stream that just digs out the channel and deepens it. You want to make sure that the water, and we're going to model this again, looking at the velocities, you want to make sure you're not suddenly increasing them and adding to that erosion. So.
Yeah, I just want to add to that, like that specific alternative was at Mill Street, where we've seen documented aggradation. Right. You would never do that up in the river, because the biggest issue with Great Brook is it's cut down too much. Right. That's what's initiated all the landsliding. The model clearly shows that it's the bridges and the road squeezing the river that puts all those red velocity zones there. So like, even though a lot of sediment goes into Great Brook, it gets shoved down into the village, fills the channel, and spreads the water out.
Well, one of the reasons I brought this up is because a lot of people feel that that is a big solution. Yeah. Is to dig out the sediment, create a bigger, deeper channel. Mm-hmm. But,
here's the thing. If you look at the channel, like, there are floodplains that are now very disconnected. Even in this large flood that went through a couple years ago now, like, the water didn't get onto those floodplains. Yeah. So the river is kind of stuck in a lot of critical spots, including the Grand Canyon spot up like between Fowler and Gray. Like, those flood benches are way too high now. So what we want to do is get those connected and get sediment building up in the channel, because as you spread the water out, it's less erosive and it's less apt to sort of cut and jump out of the channel. And that's what you see all along Great Brook. It's a little counterintuitive. So the model helps us pick the spots where we can spread that water out and dissipate the energy. It's all about dissipating energy. But the issue is if you have a constriction, every half mile on that brook, and the stuff just can't get through it. So you can try to create it.
Just going back to his question as well about the roughening, kind of relates to that. It's like you have kind of two options when the channel suddenly cuts down. If you wanted to reconnect to its floodplain, you can either build it back up and try to get it onto the floodplain, or you can drop the floodplain down and try to match what the new bed elevation is. And so if we're kind of just thinking of that, right, what we might do in some cases, we might cut the floodplain down and say, well, this is where the brook is, we can't really raise it up, it's too difficult, it's cut down 10 feet, we can't just fill all that in. Or we might do the reverse and say, actually, this isn't that deep, we could throw some wood in here, we could put some rocks that are kind of slow it down, roughen it up, and then maybe it naturally builds back. That's kind of two options of trying to do the same sort of thing, is just slow the water down and get it to spread versus keep it in that narrow confined channel.
Charlie's question.
Yes.
Yeah, a real follow-up to that about debris in the channel. It isn't just rocks that roughen it up.
Yeah.
It's wood, it's debris jams, and I wonder if your model looks at debris, especially the debris affects the bridge. It aggravates the narrowness of the bridge. Secondly, have you built in any empirical data of the jams to predict what would happen if you took the debris out of the channel or you left the debris in the channel? For 50 years, this town has argued on two alternatives to prevent the floods and damaging floods. They are diametrically opposed. One is to remove the debris. Now that might be minor, it might be the bridges that are at fault, not the debris. But they've argued that the debris is causing a major part of the problem. To the point where, on their own, the Agency of Transportation cleared the debris out of the brook after the 2024 flood. Does your model, or can your model, look at those to see which ones are logical, which ones actually happened, which ones do we expect in the future? And my final point is, all of your modeling is done on a post-2024 topographic.
Yeah.
The floodplain, the channel, expanded by 75% during the 24 flood. We have greater floodplains. Therefore, all of your models are predicting a better environment for capturing water in volume than what actually happened in the flood.
Yeah.
So, I think you should run your model on a 2023 topography.
Wow, so there's a lot of items there.
Yeah. Explain the validation step we just did.
Yeah. So I would say yes, is it yes to all of those? There's a lot, I'm not sure how many. I guess first is, when I showed earlier that validation, I showed that yellow line and the blue line, one of the things we did was initially is like, okay, well, our lines aren't quite matching why the bridges are clogged with debris, the channel is different, something has happened, something back and forth. So the first step was fill the bridge to the B. And so we can do that. In our model, we can change the ground elevation, or we can change what we call the roughness in the bridge. We can change these factors and say what is happening. And this is kind of replicating if you threw wood in there, if you threw rocks in there, if that all gets jammed in. And so we can do that, and we use that to kind of say like, okay, in this case, right, we tried to clog the bridges up a little bit, about 50%. That's kind of what we're like, let's try 50% just to see what happens. And then we started matching those lines better. And so we'll probably be doing that for a lot of stuff. And when we try the new bridges, we're also going to do that. We're going to say, all right, well, this is now a 80-foot bridge. It's much closer to what it should be. But let's say it gets filled with sediment because the bank fails upstream. Like we have these crazy giant slope failures where you have suddenly the river cuts and you have the sediment come down, and you have the trees. Yeah. And so that washes into your bridge. Even if it's a good sized bridge, even if it should pass the flood, it's still going to be full of stuff. So we can try that. And that's what we will try, is that we try alternatives. We're also probably going to fill things up a little bit to see how that happens. I'm trying to think of all other things.
Yeah, we have a great empirical model.
Yeah.
Let's have a great theoretical model.
How are we
I
doing?
think part of his question was to remove or not to
Yeah.
remove.
Okay, you want
Yeah, I mean, I guess so,
A couple of things, so when V-Trans came through to clean the wood out, we finally got activated on call for flood recovery through DEC. And we started walking around with them and saying, here's the wood you want to leave, because it's actually like capturing sediment and the river's wide. And then here's the wood in front of the structures. So the answer, your answer is like, you kind of know the answer. Like in undersized structures, debris is a nightmare, right? Like it will clog them instantly and then the river jumps out and it's damage to the road or something. But in these open floodplains, the debris is actually really important to stabilize the channel and keep the river from cutting down more and initiating more landslides. So the answer is kind of both, and it depends where you are. If you're on the string or the pearl sections, right? Like that's what they say rivers are. They're long, thin areas and they're big, wide areas. They're long, thin, and big, wide. Those big, wide areas are really essential to have debris in them to keep them stable. And then they kind of, if you have enough of those, they stabilize the sections. In
So can we quote you?
You can.
So I have
You
a
should
question.
keep the debris in the channel.
You want to keep the debris in the channel and
Not
then,
the bridge.
so, and I don't know if you all remember this, I could pull it back up, but, you know, a bunch of years ago, UVM did a study when we first started looking at the bottom two bridges, Mill Street and Brook Road. And everyone's like, no debris goes through the bridges. And what they found was they did drone surveys before and after floods. And all the wood went through the bridges until the bridges filled with water. And then the bet was off. Then the wood was floating and it jammed up. And so we've watched these bridges jam, but they transport wood through them. If you get the right size bridge in there, the wood's going to go through the system and it's not going to be as damaging. It's all about the structures, really.
The
They
Mill
have to
Street
be the
Bridge
right
did not
size.
jam. I mean, that was typically the case. The Brook Road Bridge almost always jammed, and the Mill
Yeah.
Street Bridge rarely jammed. And what happened in 2024 is the Mill Street Bridge was unable to pass a 2026 Honda Civic. I mean, that's basically the trigger for pushing it off its foundation, is it was temporarily clogged with a brand new car.
Wow.
Yeah, so,
And I did that analysis.
Yeah.
75% of the debris in the channel after 2023 passed into the Winooski.
Yeah.
75% passed.
Mhm.
Of the 25% that didn't pass, at least half of that never had to go under a bridge. And then the Agency of Transportation took it off.
Yeah.
Francis Rose?
Yeah, I think there's an opportunity, what I'm hearing centrally, this is less a question to be settled tonight. I did hear that you are planning to return for multiple more presentations to the town ahead. If there could be a slide or two, that could be a teaching moment for the entire town, tuning in to describe the phenomena that you are describing and that you are describing, Charlie, both. It could be a learning moment. It is an opportunity to present visual evidence to a town that is divided about how to handle this matter of debris in the Brook corridor. Thank you.
You have more slides? Yeah, you want to keep going?
we had one more.
Yeah.
Sorry.
We'll finish it up.
It was really just, yeah. Go ahead, Ethan.
All right. It's pretty much just a summary of all the things we were talking about. These are our list of kind of broad alternative categories, right? You're seeing floodplains, you're seeing bridge replacements, realignment of Brook Road, stabilization, removal of stabilization measures that kind of stick out in the channel and push the water. So this is kind of summarizing that location, and then we're going to start looking into each of these as we go. So we're starting with the floodplains, we're starting with the bridges, and we're kind of working our way through, and then we're going to start to present more of those results.
Yeah, and just one last thing on that. I mean, we're getting here to the time where we need to make some decisions. Let me make sure this is on. So not only do we want to hear things, if we're hearing some good questions that we can come back and answer with the modeling, but also we owe the state a couple concept designs and some benefit cost analysis to see if the projects that are good for flood mitigation are cost effective. And the idea is that these will be packaged and ready for the town to submit for a hazard mitigation grant. So, but because we're scrunched a little because of our data collection lag, like we kind of are going to be moving a little bit quicker. We'll come back one more time with a bunch of results, and then we need to make decisions to make some concept designs to prepare that last important deliverable for the project by November. So I just wanted to throw that out there that we kind of need some input from people on this is what we want to do. I mean, to me, it seems like the initial alternative, connecting with the designers of Mill Street and then like taking advantage of whatever buyouts happen in the village, like that, those should be floodplain restoration areas. Something needs to be done up at the Narrows where the Grand Canyon is, where the Brook Road fails, and then there's a couple more spots in the village we have our eyes on. So those are probably the top candidates right now in our minds, but we would like to hear from others if you have ideas.
I'm just sitting here with a takeaway after hearing all this, and one of the comments that really stuck with me was how complex this brook system is, and how most communities around the country their solution has been to move away from this type of complexity and just put the road somewhere else. And but what I've noticed is that I've been to a lot of meetings like this, and I never hear anybody talking about or beginning to think about moving the road. And it just seems like it's almost guaranteed that the frequency of these events is going to go up. So saving this road is starting to seem more and more like folly to me.
One thing I did want to make sure you work with the engineers on, one of our bridges on Brook Road, I think it's 24, was our newest bridge. And yet the force of the water undercut the base of that bridge and lifted it off its foundation and pushed it out of the way, and it broke. It failed. So there's solutions, I think, that they're thinking about, such as sheet piers and other things that will prevent that from happening. But I just want to make sure if there's any information you can share with them to make sure that that doesn't happen to a new bridge. That'd be really important.
I'm just thinking of a hypothetical, which is if the road is moved, would it still make sense to repair parts of the brook? Because the brook is so damaged, it will continue to erode, I'm guessing, unless floodplains are, mitigated and that kind of thing, and bridges are widened. So even if the road got moved, it seems like we will need to do repairs on the channel and the floodplain and the bridges.
Yeah, there definitely might be some. So let's say you have those giant slope failures where there's adding sediment, there might be stabilization measures that we could implement, softer solutions, potentially plantings, potentially, installing wood at the toe. The stream will naturally, return. It takes time. If you give it room, it can do it faster, right? It can do its own thing. It does take a while though for the stream to stabilize. So there is, we can try to speed that up in some spots where we think maybe it's causing an issue. And there could be ideas to soften it or to fix certain parts that are still so unstable, such as head cuts, things like that. You could do some stabilization, but at the same time, the stream will, on its own, eventually, as those slopes keep failing, eventually they will flatten out. Eventually you'll get enough wood at the toe that it starts to kind of build back and revegetate. It just takes a lot of time, but there could be other options.
Well,
there's a bigger, tougher question that I'd like to throw in here, following up on what Jen asked, which is that, first of all, people live there, that's for sure.
Yeah.
And they certainly want to not be trapped in their homes without an ability to get out of there. But the other side of the coin that pushes against that is that the bridges, it's almost like if anybody knew what the Brook would really do, and if anybody knew what climate would really do, they wouldn't necessarily have built roads where they've built roads, and they wouldn't have built a village where they built a village. And now the Brook Road itself is an obstruction to the Brook. Should the Brook Road be moved, would it not also be part of the question about how much of our infrastructure should be torn out, like remove those bridges that are in the road, do you actually, whatever the word is, restore the floodplain by taking out infrastructure?
Yeah, that's where I was going with it, like, the removal of the road that sits in the floodplain is the project. Like, if you're not just gonna sit there and leave this giant fill, and honestly, you're probably gonna use some of that to build a new road, so you would kind of restore that floodplain as part of that project. Some of those bridges probably go away, and so all of that is kind of opening up. And then I really agree with Ethan, like, this is a sediment-rich system. If you give it the space, it's gonna move this stuff down through and kind of restabilize. Like, it just needs the space to get the meander space and the sediment transport it needs to stabilize. That's what we know about rivers. If you give them the space, they're going to stabilize and be less damaging.
Have we had questions online, Francis Rose?
Just one, and it was how to reach out to ask questions or offer feedback.
Yeah, and people should feel free to reach out to myself or Ethan, and we'd love to hear your thoughts and questions.
Another one, is the survey still open? The survey 123?
That was
not provided by VHB.
That was the other
VHB.
project. Yeah.
That was the other firm.
Wait, is it still open? Does anyone know?
The survey is now closed.
The engineers.
I think it is now closed.
I think it's
Yes.
closed. Someone just said it on the online here.
Did you also have a question? I feel like you would. Or...
Well, yeah, I'm gonna ask, I'm sitting here thinking, but I will. So this is maybe the kind of question that you guys talk about after work when you're having beer and you're not with the client, but I'll ask it anyway. Looking at the complexity of this, and I know you guys are professionals and I trust you and grateful you're part of this, so I mean no disrespect. There's a certain amount of hubris or chutzpah involved in thinking we can engineer our way out of this. And I wonder how you sit with that. And this is a philosophical question more than a tactical question, and if you want to pass, feel free to pass, but I'm curious about that.
Do you want?
I would say it's a give and take, right? And we're here to help people. We're here to figure out a solution for folks that lost the road, folks that want to have access to the town, to emergency services. And it's also a money question, and it's also a feasibility question. It's like there's so many aspects to it, and I think it's a give and take. Like in some places, maybe we say this is a priority, and like we want to keep this section of road. This is like we really need this. It helps with emergency services. And other sections, maybe where we have that spot where you had the road wash out 3 spots in a row, and it's just such a high energy, high risk area. Maybe you say, no, this is not worth it. But I think it's a balance, right? It's like, do we have the money to repair this, and will it last? And then your question of what flood was this? Was it the 100-year, the 500-year? We usually have to choose one of those. We have to, most of the time, most of our stuff, you always hear the 100-year because that's what FEMA and just the government has said 1% chance. That's what we're willing to accept. But that's changing. It's becoming a larger chance every year. So I think it's still a balance. Like no matter what happens, no matter what flood we select, we say we're designing to the 1,000-year flood, which they do sometimes do. Eventually, there'll still be a flood that breaks that. Eventually, So there's there's a certain point where you have to say, we're gonna try our best, and if it's above that, it just happened. But, we have to make those decisions and what's important to us, I think based on what people said, based off what the money, what economically is feasible, and then also just like, what engineering wise is feasible. Can we put stuff in that can last for a while? And I don't know. I don't know if that answered the question well or kind of broad, but I don't know if Roy wants to add to it.
Yeah, no, it's a great question. I like it. I guess what I'd say is like, if there were a silver bullet for this great brook, like the town would have done it many years ago. So we're kind of working in like the thin line. So we got really good data now. And we can just tell you, like if you restore all the floodplains and take all the bridges out, you drop the flood levels 3 feet, but that's not, then nobody can live here. So you kind of back it off and the goal for us is to find the middle ground. And like Ethan said, you do the best you can. There's going to be residual risk in some of these spots, and other spots you just hope will get a lot safer. Like if you make Mill Street Bridge wider and reconnect a few floodplains and drop the water 2 feet, it's a safer place. Now, is that worth $1 million or $5 million? That's what we got to figure out. But no hubris, honestly. The river kind of rules, and we're doing our best to kind of live in harmony with it, honestly.
It's a little tough to follow that question because I think it was really excellent. I have a small question about the dam. Removing the dam is going to help with Winooski flooding. It's not going to particularly help with Brook flooding. Is that right?
Correct. Yeah.
Okay. So that's all. That's that question. The other one is that I think most of us in this room, and a lot of people have thought about it for a year or more, lean towards replacing a big part of the road. And sometimes it's justified as less expensive because it doesn't involve so many bridges, and it's cheaper to build a gravel road than to put in all these multi-million-dollar bridges. But we're also talking about restoring the stream bed regardless in one way or another. And so I'm a little worried about, I think we're going to have to make some compromises in regards to that because of the economics. And what was encouraging was you saying that if you just leave the stream to do what it's going to do, ultimately it will stabilize all by itself. I don't know that we want to wait 150 years for that to happen, but that is one way for us to save some money. We don't have to do a lot of reclamation. Maybe we break up bridges and cart them away, and maybe we stabilize a couple of the biggest banks, but try to minimize the perfect restoration of the river so we can afford to build a new road.
Yeah.
That's my comment.
So I think I just want to be clear about giving the river the space and backing away and letting it stabilize, right? So right now there are spots that damage frequently. One of them is the Brook Road piece as you cross Bridge 21, the first bridge on Brook Road, moving up the hill upstream. Like that section that failed and was rebuilt during this flood has failed many times in the past 50, 100 years or so. Like that river's not going to stabilize in that spot with that configuration. Like the homes, the constriction, and the 90-degree turn there. Something has to be done there, or else the river's constantly going to be damaged and flooding and try to jump through that road. So there's a couple critical spots now there are wider spots where the river will stabilize. So the thought was find the spots where you really have to open the river up and give it the space, and hopefully there's the ability to reconnect some more floodplain in there or improve the structure, and then the river will stabilize once you give it the space it needs.
I'd like to ask for an outcome in this case. When you showed the model of the floodplain taking the center of the village in an area that would potentially be repeated the next time we had 4,000 cubic feet of water coming through the village again, like in 2024. You were very clear about what areas were likely unlivable. You were quite clear that in that kind of scenario, which was based on 5.5 to 6.5 inches of rain over a certain period of time, if that is likely to occur again, and I believe it is, then we also should, with our planning commission and with our road commission and our sewer and water people, be planning how our infrastructure should look if that part of the village is in fact repeatedly destroyed over the next 20-year period, twice more, let's say. In other words, your help would be very much appreciated to see where things are kind of a bad idea and to be really clear about that. That's my request.
Thank you, guys.
Any more questions in the house? Okay.
If we have specific conversations we want to have with you guys about parts of the Brook, how do we get in touch with you?
Yeah, good. I mean, we just gave our,
I can pull it up in the chat.
yeah, maybe our email is gonna get put up there.
And then it was.
Our ship.
It's my first initial and, yeah. Yeah, feel free to reach out and we'll be happy to, if you prefer to talk on the phone, just give us a number and we'll call you and talk a little bit. And if it really builds up, we can come to town and hang out and talk to various folks.
I got that right, Ethan?
Perfect.
Well, thanks to the Hazard Mitigation Committee and whoever else helped to organize this.
And then,
Thank you.
Yeah.
Thank you guys very much. Appreciate this update. So that concludes the presentation aspect of this meeting. The Hazard Mitigation Committee still has about another 10 minutes to go, but which you're welcome to stay for. But we're just going to do a little bit of planning because we have a meeting in August, we have a meeting in September. So thank you all for attending and for your thoughts. This will be and was recorded, so if anybody wants to review what was said, it's going to be up on the town website.
We gave you the presentation on the town website too, if you want to.
Okay, great, yeah, so presentation will be put up on the town website as well.
I live at 36 Hudson.
Yeah, more data than just we had a gauge that had 500 years.
So, I just like to talk to you about observations I've made. The base
The more
of
data, the more, more time figuring out
base of the bed of the Brook by our house is about, I guess, 5 feet higher than it was before the flood.
We surveyed it, there were those granite blocks.
Yeah, that's what I'm going with.
So it was about 1 to 2 feet is what we thought, and we had a pre and post survey.
Excuse me, folks, but this is our monitor for recording.
My secret was not like sitting in these chairs. I know. Yeah. So if I look at those,
Anyway, we did some survey there. Yeah, it's a very complex. I stopped working. It is like a futuristic thing, so it doesn't sound like it is. So it's hard to describe that.
Yeah, well, I mean,
So Maggie, I got the names of the people who are here online from Rose Paul, Francis Rose. Looking at Rose Paul on my
This
list.
is a young bear.
Younger, oh yeah.
So your thought to remove
Bear.
Yeah, so
So who, let's see.
Yeah, no, I mean,
I think David has the full list of people who are present in the house.
I heard my name, but I didn't
I
understand.
mean, do you guys record this for select board meetings? Like
Hill,
recording
David Hill,
attendees
people
is
who
not
are
necessarily a thing, right?
Maggie
So-
Baird, Francis Rose.
So I believe what the state statutes say is record the names of the people who are contributing to the
Rose
meeting.
Paul, Carl Bissett, Mary.
So we're not necessarily taking a full census of everyone present,
Tyler, what's your last name?
but if they had contributions to the meeting, that would be
Okay.
nice.
So that's another thing.
Yeah.
I mean,
Oh, okay.
if the
I mean,
concrete, that top plate
ask
road.
There's one up
to-
here, David, if you.
say their
There's
name
one up
again,
here.
remember, like somebody, like,
I think
Just up
three
the
of the
top of the
record.
screen.
he said he had the names, but I just wanted to.
Oh, no, I mean, like when you ask a question in the room,
Oh,
they
yeah,
should be
yeah.
saying your name before
Yeah.
you speak.
That would be helpful
Yeah.
for the record keeper.
like that's up to my out,
Yeah.
So,
There's a lot of material out there.
just
And then the
to
question
kind of
is,
refocus
does
so
the
we can
East Street Bridge
wrap this
still
up
as
to
narrow as it
ourselves.
used to be, or is it now a
Next,
big?
I'm at a pretty
meeting.
We made a giant bridge in there, because that's what you really need to,
we have
everything's
a,
funneling out, like you kind of need a big
an
bridge.
ongoing discussion that started a year ago
Something you
with the
really
Marshfield
need
Resilience
to
Fund,
water.
and we would like to add to it the Plainfield Resilience Fund, whatever shape or form it takes. So with
And maybe it's somewhere in between.
3-4 weeks of preparation, the suggestion is that we make the theme of the August meeting, what is resilience? And how is that defined on a local level? And how is it addressed? And have that as our featured discussion with the two resilience hubs for the two communities. How's that sit with everyone?
I think that's great, but so what is that, so would that be a public forum?
It would be our meeting.
Regular meeting.
Okay,
It would
regular,
be our meeting, it would be on Zoom,
yeah.
and it would involve probably at least 3 people from each of the resilience hubs, along with the Hazard Mitigation Committee, which is a resilience organization in its own right, and figure out what the best way locally is to actually achieve resilience as opposed to just conceptualize it.
Yeah.
It does presuppose availability, that 6 members of both hubs will be available at 7 o'clock on the third Thursday
That's
That would
true.
have
next
to be
month. And, you know, it's a risk to declare it
Yeah.
without clarifying.
Well, 4 weeks is really all we generally have in terms of any subject that we cover, and we lose people each time. There's almost no way not to, but hopefully we'll get the main players if we invite people very
Well,
soon.
we don't have September covered yet either, so.
No, we don't have September
We
covered, and
could
perhaps it
offer
would be
both
better to talk about it in terms of September. I do also know that we have a pending meeting with Green Mountain Power to talk about the dam. And the other thing that we sometimes do is we sometimes take August off. We don't actually
what an
meet
idea.
in August.
I would be really interested in meeting in September.
So you would like it either to be in August or October?
Yes.
Okay.
You know, one thing I know about resilience is it's hard to put it, you know, put a point on it in one time, in one place. I mean, in other words, it can be,
Oh, yeah, they come back in October.
resilience can be so many things. It seems like that's a big conversation to me.
Originally, October was the requested date, but the LiDAR was late, so I think Roy mentioned November.
He actually asked for yet an extra meeting. That doesn't have to coincide with hazard mitigation. In other words, we can just do that in between. But my sense is that we dove pretty deeply into the concept of resilience with Tom Multeney when he brought the Resilience Hub Toolkit to us for evaluation and as a draft, and asked for us to talk about that. Given that this committee has been focused on community resilience, that's what hazard mitigation is. You know what the bad things are in the future and you prepare for them. So it takes different names, as I mentioned to Francis Rose, it's that hazard mitigation is one of the names that resilience has been given. That's really was
preempted by the use of resilience in 2016 approximately. That's when FEMA decided that was the watchword from which their projects would be named that would attract money, so a lot of organizations sprung up with the word resilience in there. But it doesn't change the overall objective, which is to get your community ready for a disaster. How much of a shift do you have to have in your thinking, and what do you need to accomplish? And the Resilience Hub Toolkit actually was an extraordinary document to address that. And so when we talked about that together, we had a bit of an inkling of how big a job it is. I'm not saying we made any progress on that job. I mean, it's so huge. It involves, do you have a barter economy or introduce alternative currency? Do you, all that kind of
That's
stuff.
it. I mean, it's such a big potentially a big topic. And hazard mitigation is one element of it for a community, but there are so many others. So I guess I'm just wondering how we would talk about this if we did it during a regular meeting.
I would suggest that what we do is ask everybody to get together and deal with how big the concept is. In other words, not to solve anything, but just to deal with how big the concept is.
Put some parameters.
Lay the groundwork from which perhaps Plainfield Resilience Hub is the answer, in which case they would pick up the flag and move forward with a list of chores, and maybe not. Or maybe Plainfield and Marshfield, which is much more along the way I've been thinking, Plainfield and Marshfield be one resilience group because our communities are so interwoven and our hazards are so shared and our food resources are so shared. In other words, to have a resource directory that just does Plainfield and ignores Marshfield.
Right.
We decided back in 2011 when there was 2014 when the RAMP program called Revitalizing Plainfield and Marshfield, I think it was, and it was funded by the same people. They talked about and wanted to have a resource directory for both towns simultaneously, because our farmers aren't just our farmers.
So I think, I had actually suggested the meeting, because I've been fielding requests from the Resilience Hub to be involved, and I don't have the time or capacity for it right now. And I know that Michael has a history in working in a bunch of different types of resiliency adjacent or direct organizations or involvement. So I think the idea is to have a brainstorm, talk about what each individual group's goals are, because for me, I think our specific hazard mitigation goals are more directly related to like town people and infrastructure in relation to hazard events, you know what I mean? Like, I can't remember the precise term, you know what I mean? And like how to either give advice to the select board or how to start conversations or public education, but it's more, to me, it's more specific. Like, I mean, our goal in terms of like my 3 years on the hazard mitigation committee has been more like in response or in prevention of more of like primarily natural disasters. Whereas like I see the Resilience Hub in Marshfield doing a lot more like social things, you know what I mean?
Yeah.
And community integration group, you know what I mean? So I feel like they aren't necessarily the exact same objective. So I think the whole entire goal of the meeting would be, let's figure out what each other's individual, like let's understand what each other's individual objectives are and how we can contribute feedback or suggestions to one another, you know what I mean? Like versus.
Well, I think it's a really good question, whether we combine forces and become one hub. Is that what you were suggesting, Michael?
Well, I was saying it's an old question that I've been faced with a number of times, and it always comes back to the same thing. When you talk about organizing a community, you generally forget the community already has an organization. In other words, there are parent-teacher clubs, or there are farmers organizations or farmers markets. These are all part of existing organization. And the question becomes, how do these coordinate together so that you increase your community's survivability? You have a number of kinds of disasters. Many of them are natural, but what if there is, as we did discuss in this committee, a total loss of power because there's a coronal mass ejection, and it's not going to come back. So you're suddenly a community without power and communication. Are we ready for that? And so having it's not like we have to, what's more unnatural is that there are geographic boundaries that say Marshfield stops here and Plainfield starts there. That's much more unnatural. In fact, we all go to each other's events, and our kids go to the same school, and we date the same people from both communities. We get married to the same people in the same communities, and we have shared churches and shared health center and all that other stuff. And so if we take that as our reality, how do we maximize the resilience of our existing organization so that it can take stress, so it can be recover itself quickly? And in 2024, we actually did a pretty damn good job considering how devastating that flood was. And all of our community emerged from churches, although there are people who really think that churches are suspicious. It was the churches that actually made the huge difference in how quickly we could respond to that, because the Southern Baptists and the Mennonites and the Enough Ministries were the people that actually pulled us through for the large part and organized us and got us ready. And you know, you can be uncomfortable with churches. I'm not a Christian, you know, but the point is that if you recognize their capability, just like recognizing the capability of the Army, I mean, we called on the National Guard because they know how to move stuff quickly, right? And so I think we could just kind of argue it out and see what can we rely on, what's already in place that has a stable resource capacity, and how do we talk with each other? And can we actually save the least of us, who is the most vulnerable, the ones that I worry about the most?
You know, when I think about this problem, I often think in those terms. It's all about networks. And a lot of people are already plugged in. They're part of the church, they're part of the town meetings, they know their neighbors. They're plugged in. But the problem is are the people that aren't plugged in. They're isolated. And for me, a resiliency effort needs to figure out, even if it's without their cooperation, how do you connect those isolated people? Or how do you get to those isolated people? Who checks on them? Who checks on people who don't participate in local government, who don't come to meetings, and who aren't, you know, part of the connection, the networks? That's, for me, those are the vulnerable people who are going to end up in trouble and perhaps need to be saved or found or.
Well, that certainly would be part of resilience.
Proposal to the meeting is to bring that to the groups of people who are independently working on it, you know what I mean, and discussing the things that we see, you know what I mean, and.
But are we inviting the senior center, which does Meals on Wheels, which takes most of the people who can't come into town for food or for grocery shopping and takes care of their needs?
So they already have a list of addresses of people who are not.
But we don't invite the senior center to our meeting. I mean, they are in fact one of those extraordinarily.
Well, now that you have mentioned it, let's invite the senior center to the meeting.
So here's my concern.
In Plainfield, but I still don't understand that boundary from Plainfield to like East Montpelier.
Technically, they're in East Montpelier. It's Coburn Road.
Well,
so, like, that's why the co-op is technically in East Montpelier.
The thing is, as soon as you know, I think a lot about this. In a Carrington type event, we're talking a reversion back to two centuries ago. You're not going to be driving around in a car anymore. You're not going to have a cell phone anymore. I have no idea what that would do to our world. I mean, I don't know who can survive that and who can't survive that. But I think a lot about it. I built a farm. It's got apple trees on it. I think a lot about what am I going to eat if I couldn't get food from the outside world.
This is part of it, is resilience can be a massive topic, really.
I mean,
and
I don't know.
I'm wondering
how
if
you even start.
So if we have
bicycles, you need bicycles.
Yeah.
You need
if we have an
horses.
hour and a half for a typical meeting, how would we structure that hour and a half such that at the end of the meeting, we have moved forward on this
Why
conversation?
does
I
it just
think
need
for-
to be one meeting?
Well,
Yeah,
so that was
and I
another of
think
my
for me,
questions.
it's understanding what the individual goals of each things are so that we understand what other people are working on.
Yeah.
How do you eat an elephant? One bite at a time, right? Like if we
Yeah,
don't
so it may be
understand
a
what.
series of conversations.
Like, to me, the formation of just the basis of understanding of like, here's what each individual group's goals are as stated currently, you know what I mean? And then suggestions either for expansion, or if they want suggestions or don't want suggestions, you know what I mean? Like, that just depends.
So I think it would be really helpful to have an agenda that is facilitated, because we could, this topic could be so big. We could spend all our time sort of saying, what if this, and how about that, and, which is part of the process. But, it'd be nice to really sort of capture some of the value that Marshfield has developed in their hub.
In theory, this could be something where we meet like every 3 months so that we can make specific progress and make it faster.
Yeah.
Rather than just,
Yeah, it may need to be a
one here,
series.
one there, have it
Right.
very
Well, I can-
structured as to when those.
But again,
meetings
we
are.
have no idea if these other groups want to be involved in
Yeah.
this kind of thing. So I don't think there's any point in hashing out what it's going to be without there being an initial discussion of what do we want it to be.
Well, as Francis
you know
Rose
what I
said, if
mean?
we want Marshfield to come, we would need to invite them right away.
And it
So
makes
that-
sense because a larger pool of people, there's gonna be a lot more skills.
Yeah,
There's
but-
people in Marshfield like.
I should also say that in answer to Carla's point, that it can in fact be done, even to deal with a Carrington-style event, which is basically when everything electrically reliant is no longer available, whether it's communications or any manufacturing, whatever. Putney was one of a number of towns that actually took this seriously and dove into it, but it meant meeting once a week. That the people who were doing it were organized by the dozens, not by the ones, and that there were approximately 300 people involved with the effort, but that included people who were learning how to use horse-drawn wagons to pull wood out of the woods, people who were using mechanical saws, people who were making their own soap, people who were beekeeping, people who were computer programming learning to beekeep, because every single skill that anyone was making their living from probably would collapse and needed to be replaced with something more 19th century. And so they really were doing that. They had skill building of 19th century skills with hundreds of people. When they had the big meetings, there were like 200 people in the room. And all of the town was supporting this in the sense the emergency management director, the town select board, the town clerk. We were working on alternative local power generation for a refuge zone where you could have a community kitchen, a community infirmary, and a child care center, as well as municipal government that would be serviced by limited amount of electricity. Plus, I know from direct experience of being embedded there and running 2 of the groups there before I came back to Plainfield. I did the resource mapping group and I did the shared sufficiency group. And each one of them, we were meeting every week.
Yeah.
And you have to be able to say, our survival as a community requires investment. We're none of us going to get paid for this. We have to volunteer way beyond what we think is our capacity and be dependable and reliant so that we can count on each other a year from now, not just a week from now. And everybody made that commitment. It's a big deal.
That's amazing,
It's
really.
a big deal.
Well, it's a.
May we talk about this during the meeting? It's 9 o'clock.
Yeah. Oh, I didn't know it was that late. I thought it was only
I'm
8:30.
responsible for getting this
Yeah.
tucked away.
Well, and that's why I was like,
would be
let's stop
I would be
hashing it out
excusing
here.
myself
This
if I
is,
wasn't.
this is the hash out for the meeting.
Okay, well, thank you for reminding me, Francis. I thought it was
Well,
only.
see, this is the thing.
My
We
back's
could
to the
talk
I guess
clock.
that's all I have to do is say, I want to go
night.
home.
Well, we
Okay,
have to define the scope of
Yeah, I
what we're
need to take
talking
my
about.
medications also, because I'll
Yeah.
start not breathing.
Okay, we don't want that, David.
well, what I'll do is I'll ask you to provide me with a list of bullet points that we should try to address. And I'll see if they overlap each other and sound like they're equivalent and come up with something that would be like, let's try to at least do these 4 things.
Yeah,
And
yeah, I
invite
think,
everybody.
yes, we'll have to define it.
Yeah.
And it will have to be facilitated so that we move sort of the conversation forward,
Yeah.
I think.
Yeah,
We
okay.
can
And
send
it
some
doesn't have to
emails.
happen, fast, but it would be great to see movement.
Thank you.
Okay,
All right,
yes, thank
so-
you for reminding us
I
of the
believe
time.
minutes also are on the agenda.
All right, I would move that we
adjourn our committee?
No, I think minutes.
Oh, minutes, do we have minutes to look at?
Oh, minutes.
On the agenda, it says,
Yes, you're
Well, I
right.
didn't take minutes in the last meeting because I wasn't here,
Jen
so,
wasn't here.
I was not here either.
okay.
I think we only have like 2 people.
I think we didn't have, I know
I think we
what.
didn't have minutes.
We did not have quorum the last meeting.
Oh,
Yeah, it was only Michael and I.
So we didn't resolve anything.
so you said we resolved to kind of not have a
Yeah.
meeting.
So let's take off the agenda, the review of minutes, because there was not a legal meeting
Right.
that we needed to have minutes for. And now adjourn our meeting and having made a tentative plan for our August meeting.
Yes. And so the other thing, Michael, is that you said you noted who was in the room.
I did, I made a list.
Okay, can you send me that
I
list via
can,
email?
I did not make a list of who was on.
Well, Francis Rose helped me with that.
Okay, great.
So yes, and thank you again for that.
yeah. And we discussed this on the select board, what the state wants for open meeting law. In terms of naming who's here, you can name everyone that's here, but what they're looking for is contributors to the meeting.
Okay.
So in other words, those who speak?
Like, people who are here just attending need not, in the eyes of the state, be listed in the minutes.
But if somebody asks a question or has a comment,
Then their name won't be in.
yeah.
They want to know the rabble rousers.
I did not bang the hammer
Yeah, and say, you must say your
please tell me
name."
who you are every time you speak. We
Right.
didn't do
Yeah, we all
that.
forgot to
I'll
do
have to
that.
do that the next time.
Okay,
Let's
all
just
right.
put up
All
a
right.
sign.
Thank you, everyone.
Wait, we didn't vote to adjourn.
Oh, yeah. oh,
Yeah, well,
All in
he
favor?
moved.
Aye.
Moved.
Second?
Yes.
So adjourned. 9:06.
Okay. My computer chose tonight to